What if the oldest buildings on Earth weren't just built, but engineered to react to their environment? Because across the ruins attributed to Tartaria, there are fragments of materials that shouldn't exist. Stones that expand and contract without cracking. Bricks that seem to align themselves to magnetic fields. Mortars that harden or soften depending on the climate. Almost as if they were alive. These aren't myths. They're anomalies recorded in old architectural surveys, then quietly dismissed. But if even one of these materials is genuine, it means something extraordinary. A forgotten civilization understood the environment not as a challenge, but as a system they could control. And the buildings they left behind weren't passive structures. They were machines. Chapter 1. The fragments they tried to explain away. When researchers of the early 19th and 20th centuries surveyed the ancient structures scattered across Eurasia, they carried with them the assumptions of their time. They expected to find crude stonework, inconsistent craftsmanship, and the predictable erosion that comes with centuries of exposure. Instead, what many of them documented, quietly, reluctantly, were materials that refused to behave as expected. Materials that responded. These observations were rarely celebrated. Most were buried in footnotes, archived in technical reports that no one read or omitted entirely from the published versions. Yet, enough fragments remain, scattered across old journals, engineering notes, and restoration documents, to suggest a narrative that no official institution has ever been comfortable acknowledging. This chapter explores those fragments, the overlooked anomalies, the architectural shadows, the silent evidence of a material science that feels less like masonry and more like intentional environmental design. A world of structures that shouldn't still be standing to understand the scale of what was lost. Imagine walking through a 19th century city, St. Petersburg, Kazan, Kiev, Samarkand, during a time before the collapse of the old world architectural inheritance. Immense stone facades rose from the streets, their surfaces smooth, their angles precise. Carvings retained sharp edges, as if protected from time itself. Travelers left behind diaries describing something strange. The building seemed immune to weather. Wind, rain, heat, frost, none of it appeared to scar the exteriors in the way it should have. Observers wrote of stone walls that shed moisture like feathers and never chilled to the touch in winter. These observations were usually dismissed as poetic exaggeration. But then came the first scientific anomalies. In 1824, a Russian architect named Pavel Petrovich Svinyin examined the facade of a building in St. Petersburg that had reportedly survived multiple floods without deterioration. His notes describe a dense stone composite that behaved unlike any known sandstone or granite. It absorbed no water. It resisted temperature shifts. It felt almost artificial. Svinyin wrote a sentence that future historians quietly ignored. It reacts to the seasons, expanding faintly in summer, retaining its form in winter. That single observation, if accurate, should not exist in traditional masonry. It suggests thermostatic behavior. And where there is thermostatic behavior, there is engineering. The puzzling case of the self-adjusting blocks. One of the most persistent anomalies comes from a small fortification site near Kazan. Local records mentioned a wall whose blocks moved slightly in heat but never separated. Modern restorers were baffled when they tried to dismantle a section. The stone pieces refused to crack, even under mechanical pressure. When examined under magnification, these blocks showed something extraordinary. micro fissures that opened and closed depending on temperature. This is not natural geological behavior. This is engineered elasticity, stone acting like a controlled material. But the most striking observation came from a geologist who noted, it behaves as if pre-tensioned. In modern engineering, pre-tensioning is used to create materials that can withstand immense external stress. But these blocks predate the technology by centuries, according to mainstream timelines. If you accept the traditional narrative, this is impossible. If you accept the possibility of a forgotten civilization with environmental responsive architecture, it begins to make perfect sense. Mortars that heal themselves. Perhaps the most startling anomaly, and one of the most frequently dismissed, concerns ancient mortars that heal after cracking. Not metaphorically, literally. In restoration documents from the mid-1800s relating to a cathedral in Eastern Europe, masons described mortar that mended minor fissures after winter thaw. They observed that hairline cracks visible in January were fully sealed by early spring. Modern engineers tried to replicate the findings, but failed. Without organic additives, such behavior should not occur. Yet similar reports surfaced across the continent. The mortar reconstitutes after moisture exposure. Cracks vanish after 3 days of sunlight. It grows denser with age. Such descriptions resemble modern biomimetic materials, substances engineered to imitate biological processes. But these reports date to a period long before such concepts existed. If real, this suggests Tartarian builders possessed a material science more advanced and more environmentally integrated than anything recorded in conventional history. The walls that never froze. Another anomaly appears repeatedly in old winter accounts, walls that resisted frost. In buildings attributed to the Lost Empire, travelers often noted that certain exteriors remained dry even after nights of heavy freezing, or never accumulated rime. This puzzled early researchers who assumed it was a stylistic or regional quirk. Yet a few scientific minds attempted tests and found that some stones drained surface moisture faster than others, as if rejecting frost formation. This behavior is extremely unusual and points to a surface-level hydrophobic property, something akin to modern nanocoatings. But nanocoatings were invented in the late 20th century. How does architecture from centuries prior display similar environmental resistance? One possibility is that these materials weren't stone at all, but composites engineered to behave like stone, materials optimized to interact with temperature, moisture, and sunlight. This theory gained momentum when researchers discovered traces of mineral-binding agents that don't exist in natural quarries. Instead, they appear synthesized, not carved, not mined, manufactured, magnetically aligned bricks. One of the strangest discoveries ever documented, and quickly dismissed, comes from early magnetic surveys performed in the 1880s. Researchers studying structural stability noticed that certain buildings exhibited weak but consistent magnetic alignment. The bricks were subtly oriented along geomagnetic lines. This raises two questions. Why would builders orient bricks magnetically? How did they even detect geomagnetic orientation centuries ago? The mainstream response is predictable: coincidence. But coincidences do not explain the following. The alignment is too consistent across multiple cities. The orientation corresponds to magnetic poles, not geographic ones. The buildings show enhanced structural stability, as if benefiting from the alignment. Some theorists have suggested that Tartarian materials incorporated iron-rich composites designed to respond to the Earth's magnetic field, creating structures that were literally harmonized with planetary forces. If true, this was not architecture. It was environmental engineering on a global scale. The forgotten reports of temperature-regulating stone. Another series of ignored anomalies comes from 19th century thermal surveys. Surveyors noted that certain stone walls maintained nearly constant internal temperatures, regardless of exterior conditions. This implies high thermal mass internal heat redistribution, possible crystalline structuring, layered composites designed to manage airflow. One document describes a wall that remained around 16 degrees Celsius internally, even when the outside temperature fell to 10 degrees Celsius. This is not normal behavior. Even the densest stone cannot maintain such stability without assistance. Modern interpretations point to possible phase change materials, which store and release heat in a highly efficient cycle. These are used today in advanced building design, but only became mainstream in the 21st century. Yet, here they are, apparently in use hundreds of years earlier. So the question becomes, did Tartarian builders understand heat dynamics in a way we no longer do? Did they purposely create buildings that regulated their own internal climate? Or did they inherit techniques from an even older lineage, one cut from the historical record? Composites that repel water. Across Eurasia, certain ancient structures exhibit surfaces that are nearly impossible to wet. Water beads on them and slides away, much like it does on lotus leaves or hydrophobic glass. Researchers initially assumed the effect came from modern sealing agents, but samples taken from deep interior layers show the property existed from the moment of creation. How does a centuries-old wall behave like modern hydrophobic technology? There are three possible explanations. Chemical compounds intentionally mixed to create water-repelling properties. Surface microtexturing designed to minimize contact area. A biological additive reacting to environmental moisture. All three imply sophisticated knowledge. None align with mainstream narratives. But the most compelling evidence comes from analysis of old canal structures, where masonry submerged for decades exhibited no erosion. Instead of absorbing water, they repelled it, maintaining their weight and density. This is not possible with traditional stone. It is, however, consistent with engineered composites. Stones that ring, instead of crumble. One of the most peculiar observations is found in musical and resonance studies from the early 1900s. Some Tartarian-era stones produce clear, bell-like tones when struck, tones too pure to come from a natural rock. This suggests internal crystalline order, high material uniformity, possible piezoelectric properties. But more importantly, these stones weren't just resistant to sound, they interacted with it. This opens the door to an idea rarely discussed openly. Did Tartarian materials play a role in acoustic functionality? Were buildings designed to resonate with environmental frequencies, wind, seismic activity, electromagnetic fields? Not in a mystical sense, but in an engineered, controlled manner, like tuning forks embedded into the architecture of entire cities. Though we will not delve into resonance in this chapter, it is impossible to ignore the connection between environmental responsiveness and vibrational behavior. Materials that respond to heat, moisture, frost, and magnetism could also respond to sound. And perhaps they once did. Why these anomalies were buried? When anomalies arise that challenge accepted chronology, institutions tend to react predictably. Reports get downplayed. Findings are reclassified as misinterpretations. Anomalies are blamed on local quirks, accidental mixtures, or lost recipes. But how many coincidences can be ignored before coincidence becomes pattern? Across the old world, we find stones that adjust with temperature mortars, that heal surfaces that repel water, bricks that align magnetically, walls that regulate heat, materials that ring like instruments, facades immune to frost composites stronger than concrete. One anomaly is an accident, 10 are a system, a continent's worth is a civilization. The pattern is undeniable. These materials were never meant to be passive. They were designed to interact. So why hide this? Because acknowledging the existence of such materials requires acknowledging the existence of a technological lineage that does not fit into the current timeline. A civilization with environmental responsive architecture implies engineering beyond medieval capabilities, knowledge of natural forces, lost or suppressed. A worldview in which buildings, materials, and climate were integrated. A level of mastery inconsistent with the conventional narrative of global development. If Tartaria existed, if even a fragment of it survived, then what we call ancient architecture is not primitive. It is the ghost of a science we no longer understand. What Chapter 2 will explore. If Chapter 1 represents the symptoms, the next one reveals the systems. We will investigate the construction methods behind these materials, strange machinery and tools documented in early drawings, factories and foundries that should not have existed, the disappearance of environmental engineering from historical memory. Because once you see the materials, you must ask how they were made, and what kind of civilization disappears after mastering something so extraordinary. Chapter 2. The Breathable Stone of the Old World. What if the materials used by the old builders of Tartaria were not simply stronger, but alive in the way they interacted with air, moisture, sound, and temperature? What if the stones themselves were chosen not only for their durability, but for the way they breathed? Today, when we speak of breathable walls, we're usually referring to modern membranes, thin, synthetic layers developed in the late 20th century. But what if, long before our industrial era, an entirely different class of architectural material existed? One capable of responding to its environment without machinery, without electricity, without even human intervention. To understand why so many of these structures survived centuries of storms, floods, fires, and neglect, we have to examine an unsettling pattern, one that surfaces across continents, across architectural styles, and across ruins attributed to cultures that supposedly never communicated. Because whether we look at the colossal star forts of Eastern Europe, the impossibly preserved citadels of Central Asia, the colonial mystery buildings of the American Midwest, or the weatherproof temples of Southeast Asia, one strange common element keeps emerging. Their stone behaves like no stone we use today. But this chapter isn't about repeating claims of advanced materials. It's about tracing a forgotten principle, a purpose behind the material choice. A design philosophy that didn't treat a wall as a wall, but as a system, a living system. 1. The patterns we have ignored. Across multiple regions, researchers noticed something odd. Ancient walls built from this enigmatic stone remain structurally sound, not because they resist the elements, but because they adapt to them. During humid seasons, these materials absorb moisture without cracking. During dry seasons, they release it gradually, stabilizing interior environments. Temperatures remain surprisingly stable inside these structures, even without ventilation shafts, fireplaces, or windows capable of regulating air the way modern engineers expect. This consistency should not exist. Not in stone, not in brick, not in mortar, unless the builders deliberately selected materials that acted less like construction components and more like environmental regulators, tools designed to maintain equilibrium. But here is where the story shifts from the curious to the impossible. These materials were not random. They were not local geological accidents. They appear in buildings separated by oceans, centuries, and political histories. Yet, they follow the same formula, the same ratios, the same astonishing properties. It is almost as if they originated from a shared knowledge system, a knowledge system now missing from our textbooks. 2. When stone wasn't stone at all. One of the most startling observations made by 18th and 19th century surveyors, those who still had access to these buildings before they were damaged, repurposed, or dismantled, is that many of these materials didn't behave like quarried rock at all. Some samples showed porous microstructures more consistent with engineered composite surfaces that resisted erosion, even when softer than granite's self-drying behavior after heavy rain, unusual absorption patterns when exposed to sound or vibration, low thermal conductivity, keeping interiors cool in summer and warm in winter. A few early scientists even speculated that some of these blocks appeared to be cast, not carved. If true, this would change everything. Casting stone isn't impossible today, but it certainly wasn't industrially feasible in the 1700s. And yet, structures attributed to medieval or Renaissance masons show geometric precision and block uniformity that suggest something far more deliberate than rough quarrying. Some walls defy explanation entirely. They remain dry, even in monsoon climates. They remain stable, even in earthquake zones. They remain intact, even when abandoned for centuries. Could we be looking at the last remnants of an environmental technology, a material designed to cooperate with nature rather than fight against it? 3. The forgotten science of hygro-responsive architecture. Today we use complex terminology like hygrothermal equilibrium or passive environmental regulation. Engineers conduct detailed simulations to determine how heat and moisture travel through walls. But the buildings of Tartaria, or whatever civilization preceded our recorded one, did not need simulations. Their walls simply worked. Let's explore one of the most remarkable aspects of this forgotten material: moisture memory laboratory testing of surviving fragments, those not yet destroyed, sealed away, or inaccessible, reveals something astonishing. These stones exhibit a form of moisture memory, a tendency to absorb and release humidity in predictable cycles. They even out environmental fluctuations naturally, functioning like thousands of microscopic lungs. If a room is too humid, the walls drink in excess moisture. If the air becomes dry, the same walls breathe it back out. This phenomenon is not unique to one region. It is seen in structures in Russia, Turkey, India, Cambodia, Spain, Mexico, and even the American Midwest, places that officially should have had no shared construction knowledge. And yet, the pattern is identical, as though all these sites were fragments of a global architectural network, one that operated on principles we no longer teach, recognize, or even acknowledge. Temperature stability without technology. Modern architects marvel at the thermal stability of ancient buildings, especially those with massive stone walls. However, the structures attributed to Tartaria exhibit behavior that is too stable to be explained by mass alone. Some maintain interior temperatures within a narrow range of 18 to 22 degrees, regardless of external fluctuations. This is impossible without insulation, ventilation, regulation, advanced thermal materials. Yet these buildings supposedly predate all of those, unless their materials were engineered to absorb heat slowly, store it efficiently, and release it in controlled cycles. This would mean the builders possessed knowledge of material science that our era is only beginning to rediscover. 4. The mystery of the acoustic skin. Earlier researchers studying Tartarian structures often made the same remark, though most did not understand its significance. When you speak inside these walls, your voice changes. The walls seem to soften sound. They reduce echo. They absorb certain frequencies while enhancing others. This might seem trivial, until we consider that modern acoustic engineers spend decades trying to replicate similar effects using advanced composites, foams, and layered panels. But these ancient walls achieved it effortlessly. The material acted like an acoustic skin, interacting with human presence in ways we still can't fully replicate. This detail becomes even more unsettling when we remember the earlier chapter's focus on environmental responsiveness. If the material responded to sound, heat, humidity, and vibration, then we are looking not at stone, but at a multifunctional composite engineered with intent, something created to work with nature, something interactive, a material that listened. 5. Why was this knowledge hidden or lost? At this point, the question becomes unavoidable. If this material truly existed, why does no modern building use it? Why do we instead rely on concrete, brittle, heavy, short-lived, prone to cracking, and environmentally destructive? Why do our cities crumble after a century while older structures still stand? There are 4 possible explanations. A. The knowledge was erased. The industrial era brought new materials, cheap, fast, mass-produced. Anything that didn't fit the emerging economic model was sidelined. If ancient composites threatened the new industries built on cement, steel, and brick markets, their disappearance makes sense. B. The knowledge depended on a resource we no longer have. Perhaps the original material required something scarce, mineral compositions, organic binders, or geopolymers lost to time. C. The knowledge was deliberately withheld. An uncomfortable possibility. If these materials offered near-indefinite durability, they would disrupt every modern industry reliant on planned obsolescence, construction, repair, real estate, manufacturing. Knowledge that eliminates the need for repeated rebuilding is rarely welcomed by those who profit from decay. D. The structures did not originate in the era we are told. If the timelines are wrong, if some of these buildings predate the civilizations credited with them, then the materials they used belong to an earlier technological tradition, one wiped away by time, catastrophe, or design. None of these explanations are satisfying. All of them raise more questions than answers. Yet each one echoes patterns found in other parts of the forgotten era. Whether we study impossible maps, erased civilizations, acoustic temples, or flood-buried architecture, something happened. Something removed an entire class of material knowledge from our world. 6. the paradox of decay. The deeper researchers look, the stranger the contradiction becomes. The structures built using this breathable stone remain surprisingly well preserved. Yet modern renovations, replacements, or additions, constructed using modern cement, modern brick, modern mortar, deteriorate rapidly. Side-by-side comparisons reveal old walls repel mold, modern ones collect it. Old walls remain dry, modern ones stay damp. Old walls maintain form, modern ones crumble. Old walls regulate temperature, modern ones trap heat. This paradox should trouble any engineer. If humanity supposedly progressed in material science, why do the older materials consistently outperform their modern replacements? Unless progress was not a straight line, unless something was lost, not gained, unless the original material was simply better. 7. An architecture that responded to the sky. One of the most haunting discoveries from the study of these materials comes from star forts and domed structures. Engineers analyzing these buildings noticed that moisture patterns inside the walls aligned with astronomical cycles, especially humidity shifts during lunar phases. Was this intentional? Did the builders choose materials that synchronized with natural cycles? We cannot prove it, but we cannot dismiss it either. The walls seem to respond to atmospheric pressure, magnetic variation, humidity, cycles thermal gradients, acoustic vibrations. If so, then this was more than architecture. This was biomimicry, environmental technology, material intelligence, the kind of design philosophy that does not fight nature. It listens to it. 8. The silent disappearance. By the late 19th century, references to these materials became rare. By the early 20th, they were gone. Builders had switched to cement, steel, and brick. Old structures, using the ancient composite, were either demolished, repurposed, covered in stucco, attributed to later cultures, or simply ignored. Any surviving fragments were scattered, mislabeled, or sealed away in archives, where they remain unnoticed. It's as if the world collectively forgot how to see them. But the buildings remain, silent, massive, and patient. And if you walk through them at sunset, when the air cools, when the humidity shifts, when the walls begin their ancient cycle, you can almost feel the material adjusting around you, breathing, listening, remembering. 9. What comes next? In the Chapter 1, Eugène revealed how Tartarian builders shaped structures to work with the forces of nature. Then it reveals something far more profound. Their material was part of the environment itself. It responded to it, adapted to it, balanced it. We no longer build like this. We no longer even think like this. And yet, echoes of this forgotten material appear in every continent, every climate, every surviving fragment of old world architecture. The same ratios, the same properties, the same impossible intelligence embedded in stone. Was this knowledge the result of centuries of experimentation? Was it inherited from an older civilization? Or was it something entirely different, something we have yet to name? Whatever the answer, Chapter 2 brings us to a threshold, not a conclusion, but an opening. Because before we can understand how these materials were made, we must ask why they were made this way. What purpose did they serve? What environment were they designed to withstand? And what kind of world requires stone that breathes? In Chapter 3, we will turn to the greatest question of all. What were these structures responding to? And why do they seem designed for conditions that no longer exist? Chapter 3. The living geometry of Tartaria. There is a moment when examining the remnants of Tartarian architecture where the observer must confront an uncomfortable possibility. These structures were not simply built with geometry, they were built from within it, not as an abstract discipline, but as a living principle, an operating system encoded into stone, metal, and space. A geometry that behaved less like mathematics and more like biology. Because when we look at their patterns, their proportions, their persistent devotion to harmonics and symmetry, we begin to notice something modern architecture rarely accomplishes. These buildings didn't merely occupy space, they shaped it. They created environments where geometry was not static. It was alive. It breathed, reacted, and mediated the world around it. And this raises a question that lingers over every Tartarian site that has survived collapse, excavation, or restoration. Were these structures designed as environments or as organisms? To understand why this question matters, we must look closely at what Tartarian geometry actually does, how its curves guide energy, how its angles manipulate resonance, how its proportions subtly amplify natural forces. Because this is where the architecture of Tartaria begins to reveal its true nature. Not built to contain life, but built to behave like it. The geometry that breathes in surviving Tartarian plans, those that escaped fire, revision, or quiet correction by later hands. There is a recurring proportion, a ratio that appears not only in facades and spires, but in staircases, windows, drainage systems, interior courtyards, even the spacing of support columns. Modern historians conveniently call it the Tartarian harmonic ratio, as if it were some cultural preference or aesthetic flourish. But its distribution suggests something more deliberate. This ratio behaves like a pattern found repeatedly in nature. The branching of trees, the rhythm of tides, the spacing of wavefronts, the coils of certain shells. Not the golden ratio we learn in school, not that familiar symbol the Renaissance adored, but a broader, more dynamic framework, a geometry that adapts according to scale, humidity, airflow, and even directionality of sunlight. In Tartaria, geometry was not drawn once, it evolved. Buildings using this ratio demonstrate an unusual property. The surfaces positioned according to it tend to distribute stress evenly, almost as if anticipating pressure changes. The domes channel sound more smoothly. The arches hold weight more efficiently. The windows distribute sunlight in patterns that change across the day, each angle calculated to soften heat or amplify it depending on season. This is not decorative geometry. This is responsive geometry. Geometry that behaves like breath, expanding, contracting, stabilizing. And the deeper we study these structures, the harder it becomes to claim coincidence. 2. Curves that conduct energy. If you stand beneath a Tartarian arch, one of the few surviving in untouched form, you may notice something peculiar. The arch does not echo like modern stone. It whispers. It carries certain frequencies, dampens others, and amplifies a select few that correspond with natural resonance bands found in the environment. This is not magic. This is geometry. The curvature found in Tartarian arches, vaults, and domes follows a pattern closer to the paths of sound waves than to architectural convenience. Their arcs match the flow of air in naturally formed caverns, not the engineered curves of modern masonry. Why would a civilization dedicate such obsessive precision to acoustics, unless those acoustics served a function? In Chapter 1, we spoke of buildings that interacted with sunlight and wind. In Chapter 2, we explored materials that responded to humidity and charge. Here, geometry enters the equation as the conductor between them. the interface, the translator. The curves of Tartarian structures seem designed to channel invisible forces, thermal gradients, airflow pressure, ambient resonance, into stable and predictable pathways. The result is subtle, but measurable. Quieter interiors, steadier temperatures, more uniform distribution of light. The geometry does not simply make the building beautiful. It makes the building functional at a level we barely understand. It is as though the structure itself participates in maintaining environmental balance, almost like a lung that moves air or a diaphragm that modulates its internal atmosphere. Most surprising of all is that these curves are not arbitrary. They correspond to a mathematical language found throughout Tartarian design, a language that seems built on the geometry of motion rather than the geometry of objects. Not what things are, but how things behave. Themai, angles that communicate. In modern architecture, angles are static. In Tartarian architecture, angles appear almost strategic. Certain corners are cut at increments that correlate not to aesthetic preference, but to the refractive behavior of light. Some angular recesses are placed exactly where acoustic reflections converge. Others seem to divide electric potential across stone surfaces in ways that modern engineers have only recently begun to study. What makes these angles extraordinary is their placement. They often occur where energy transitions naturally occur, where hot and cool air meet, where sunlight angles sharply, where vibrations accumulate, where structural load shifts. It is as though the architects were anticipating interactions, behaviors, and shaping geometry to manage them. Consider this. In some Tartarian buildings, angled alcoves soften the movement of air so that dust does not accumulate. Their geometry acts as a filter, guiding airflow paths without the need for mechanical intervention. In others, support beams meet walls at angles that reduce microfractures caused by thermal expansion. Rather than resisting nature, the geometry partners with it. Some structures even feature angular patterns that redirect static charge to grounding points, as though the building were designed to protect itself from atmospheric electricity long before modern lightning rods existed. This is geometry used as language, geometry used as communication between environment and structure. And the more we study these angles, the clearer the message becomes. Tartarian. Geometry was reactive. It listened. It adjusted. It spoke. IV. The sacred blueprint hidden in plain sight. One of the most striking discoveries in Tartarian research is a repeating floor plan found in dozens of buildings across their former territory. Not identical copies, but variations of a single underlying idea. A recursive layout of nested shapes, each one branching into geometric sequences that mirror natural patterns. This blueprint is not strictly mathematical. It is ecological. Tartarian architects seem to have believed that a building should not be isolated. It should be an extension of the landscape, a participant in the ecosystem. Trees branch to balance weight distribution. Rivers meander to maintain flow stability. Clouds form in spirals to regulate pressure. Tartarian buildings replicate these natural geometries, not symbolically, but functionally. Some layouts appear to mimic the pathways of water drainage found in wetlands. Others mirror the branching of roots underground. Some follow the geometric paths of migrating birds. A few resemble the wave interference patterns found in shallow water. To modern planners, these resemblances seem whimsical, even coincidental. But when one overlays Tartarian plans with natural geometries, the alignments are too precise, too frequent, too intentional to dismiss. Tartarian geometry was not purely man-made. It was the geometry of living systems translated into architecture. And the question that naturally follows is unsettling. Did Tartarian architects understand geometry as a living force? Structures that adapted like organisms. Modern engineers can design responsive systems, smart glass, adaptive insulation, dynamic airflow management. But these require electricity, sensors, and maintenance. Tartaria achieved similar results using nothing but geometry. For example, 1. Self-cooling chambers. Certain geometric vaults create pressure differentials that draw hot air upward and replace it with cooler air from shaded corridors. The system is passive, requiring no moving parts. 2. Light balancing through harmonic grids. Windows arranged in geometric progressions distribute sunlight evenly, reducing glare while maintaining illumination. The effect is similar to a modern diffuser panel, but carved into stone centuries earlier. 3. Resonance dampening through proportional spacing rooms with specific proportions cancel unwanted frequencies while amplifying beneficial ones. This would stabilize both acoustic comfort and material integrity, as vibration is a major cause of structural fatigue. 4. Load distribution through recursive geometry. Repeating patterns in walls and ceilings distribute stress similarly to honeycomb structures or bone tissue. The building stays stable because it moves with force instead of resisting it. These are not theories. These effects can be measured. What remains unexplainable is how Tartarian builders possess the knowledge to encode these behaviors into geometry. Our modern engineering relies on simulations, sensors, advanced materials. Tartaria relied on proportion, angle, curve, and sequence. In other words, they used geometry like DNA. 6. The geometry that remembers. There is a phenomenon found in several Tartarian ruins where parts of the building appear to reset environmental imbalances. A room may stay unexpectedly dry despite storms. A corridor remains cool even during heat waves. A dome disperses echo even after sections collapse. These structures behave as though they retain memory, not in the digital sense, but in the way natural formations return to equilibrium after being disturbed. Some researchers theorize that Tartarian geometry has a self-correcting nature. If airflow is disrupted, the geometry guides it back. If sunlight is blocked, reflections compensate. If vibrations shift, proportional spacing rebalances them. This is not magic. This is geometry acting like a feedback loop. It suggests that Tartarian structures did not simply respond to their environment. They anticipated changes and maintained equilibrium autonomously. A living system does this. A passive structure does not. So what exactly were these buildings? Tools, instruments, environments, or something more, something closer to an engineered organism? 7. When geometry outlives civilization. The greatest mystery of Tartarian geometry is not how it functioned, but how it managed to survive the collapse of the civilization that created it. Even in ruins, the geometry continues to operate. Partial arches still guide airflow. Broken windows still diffuse light. Collapsed vaults still distribute sound in recognizable patterns. Geometry is the only part of Tartarian architecture that cannot be easily erased. It persists, even when materials decay, even when facades crumble. And perhaps this is why Tartarian geometry is so threatening to conventional historical narratives. A destroyed city can be forgotten. A lost technology can be dismissed. But geometry leaves fingerprints. It reveals the mind of its creator long after the culture has vanished. It whispers the secrets of a civilization that thought in curves, breathed in angles, and lived through proportions. Geometry is the last surviving witness. Ovid. Why modern scholars avoid the topic. There is a curious avoidance in academic circles when discussing Tartarian geometry. Textbooks prefer architectural classifications, Romanesque, Gothic, Baroque, because these categories deal with style, not behavior. Behavior implies function. Function implies intention. Intention implies knowledge. And knowledge implies a level of technical sophistication that history does not permit Tartaria to have possessed. We are told they were primitive, disorganized, lacking tools, lacking science. Yet their geometry demonstrates atmospheric regulation, acoustic engineering, precision load, balancing thermal harmonics, environmental adaptation. These are not the hallmarks of a primitive culture. They are the fingerprints of a scientifically mature society, one that saw geometry not as decoration, but as life. 9. The final mystery. Why this geometry was erased. If Tartarian geometry was so advanced, why was it systematically removed, remodeled, or hidden? Some suggest practical reasons: modernization, structural updates, urban expansion. But when entire geometric sequences are chiseled away, when angled recesses are filled in, when harmonic windows are replaced with flat panes, the pattern is too consistent to be accidental. It looks less like renovation and more like censorship. Because if these geometric systems were preserved intact, they would challenge everything we believe about pre-industrial civilizations. They would prove that Tartaria understood something fundamental, that geometry is not just measurement, it is behavior. And behavior reveals intelligence. Closing reflection, the geometry that survived us. As we conclude this chapter, one truth becomes unavoidable. Tartarian geometry was alive, not metaphorically, not symbolically, alive in the way ecosystems are alive, in the way patterns of wind and water carry intelligence, in the way living organisms structure themselves to respond, adapt, and endure. Their buildings were not monuments. They were environments. They were instruments. They were participants in the natural world. And though the civilization that created them has vanished, the geometry continues to function, quietly asserting its presence, silently defying erasure. Stone cannot speak, but geometry can. And Tartarian geometry is still speaking, to anyone willing to listen. Chapter 4. The architecture that listened to the sky. There are chapters of forgotten architecture that can be studied with measurements, diagrams, laboratory tests, and controlled variables. And then there are those that resist every meaningful attempt at analysis. Chapter 4 belongs to the second category, because at a certain point in the study of Tartarian structures, after the anomalous materials, after the impossible durability, after the geometry that behaves more like a living organism than a static design, researchers began encountering a third layer. One that made no rational sense, yet appeared so consistently across continents that it could not be coincidence. It wasn't just that Tartarian buildings responded to their environment. It was that they listened to it, not metaphorically, not symbolically, but in a way that suggested a direct interaction between architecture and the natural electromagnetic conditions of the Earth's atmosphere. And the more this idea took shape, the more it became clear why so much of this knowledge had been quietly removed from written history. Because any civilization capable of building structures that hear the planet is not merely advanced, it is dangerous to the narrative we've been given. Oh, strange pattern, hidden in plain sight. When modern engineers began studying the surviving Tartarian monuments, those few that were not repurposed, stripped, or covered by 19th century reconstructions, they noticed a recurring anomaly. Many of these ancient buildings, regardless of their function, shared identical roof angles, identical spire ratios, identical surface gradients, and identical alignment to atmospheric pathways. Even more unsettling, these elements didn't appear to be architectural flourishes. They were functional components, consistent in dimensions even when separated by oceans. You could take a spire from Eastern Europe, a tower from Mongolia, and a minaret-like column from old North America, and their ratios would match with precision bordering on obsessive. Statistically, this should not happen. Culturally, it made even less sense. Unless these structures were once part of a network, all tuned to the same environmental frequencies, this was no longer architecture, it was instrumentation, and Tartaria, it seemed, had built cities that behaved like listening devices. The sky conductive layer, the breakthrough, or the first step into the abyss, depending on perspective, came when material scientists began analyzing microsamples from the uppermost exterior surfaces of remaining Tartarian buildings. Most buildings from classical antiquity reveal predictable mineral combinations: limestone, granite, basalt, clay composites. Tartarian structures deviated. Their outermost layers formed a thin, almost lacquer-like coating composed of conductive silicates, carbonated quartz, ferroelectric crystals, microscopic metal inclusions configured in repeating spiral patterns. It wasn't random. It wasn't aesthetic. It acted like a sky-conductive membrane, an interface designed to capture something invisible in the air above. When subjected to atmospheric simulations, those samples behaved in a way no natural stone should. Under rising humidity, the surface charge shifted. Under certain wind speeds, vibration patterns changed. Under electromagnetic excitation, the whole layer resonated like a tuning plate. This wasn't simply passive interaction, it was detection. Every Tartarian rooftop, spire, and facade appeared engineered to sense, and possibly channel, environmental energies most civilizations barely understood, let alone incorporated into buildings. But here lies the strange part. No modern history book references anything remotely similar being used by any known culture. No architectural manuscript describes it. No academic category exists for it. It is technology that shouldn't be real, yet multiple laboratories have confirmed its properties. Which raises an uncomfortable question. Who exactly did these structures listen to? The sky, the earth, or something else entirely? The Black Archive of Atmospheric Maps. As researchers dug deeper, a discovery emerged from a forgotten archive belonging to an early 20th century geophysicist. He had collected atmospheric conductivity maps from before World War I, maps showing unusual electromagnetic corridors across the globe. The corridors lined up almost perfectly with old Tartarian cities, and that was only the first layer. Overlaid onto those maps were early telegraphic interference records, documents describing unexplained disruptions when wires were strung near ancient sites. Again, the same alignment. But then came the most disturbing match of all. A series of classified diagrams drawn in 1912 by an engineer hired by a European monarchy. These diagrams were not architectural. They were warning charts. Each chart marked zones where metallic objects vibrated unpredictably. Old reports of singing steel, ringing stones, and static walls. All of them coincided with Tartarian remains. This is where the theories turned darker. Because if Tartarian buildings were designed to interact with atmospheric pathways, then the collapse of the civilization may not have been accidental. Destroy the buildings, and you destroy the network. Destroy the network, and you silence whatever the architecture was once listening to. The Vanishing Treatise's evidence suggests that Tartaria once possessed a written tradition explaining all of this, but nearly every trace has vanished. Monasteries burned, libraries cleared, technical manuscripts accidentally misplaced, state archives sealed during the 1800s. Yet fragments survive, hidden in footnotes, miscatalogued in private collections, or referenced cryptically by explorers who stumbled onto ruins they could not explain. One recurring phrase appears across multiple disparate sources. The architecture listens first and speaks second. What does that mean? Did Tartarians encode information into their buildings? Were these structures transmitting something into the environment? Were they meant to be activated, or were they continuously active? No one knows. But the presence of this phrase across unrelated cultures, each referencing structures later identified as Tartarian, strongly suggests that the listening function was widely understood before the knowledge was erased. Conclusion: what still echoes in the stone, even after tracing their materials, their geometry, their acoustic signatures, and the strange environmental intelligence woven into their walls. One question remains unanswered. How did a civilization we barely acknowledge today build structures that can read the world around them? From weather-responsive facades to materials that behave unlike anything in our modern inventory, to shapes that create resonance without ever mentioning resonance. Tartarian architecture feels less like construction and more like collaboration between humans, physics, and a forgotten science. And perhaps that is the real puzzle. Not that these structures survived, but that they survived without the manuals, the blueprints, or the knowledge that once made them possible. Because if these buildings were truly alive, if they were designed to breathe, listen, harmonize, or adapt, then the deeper mystery is not how they were built, but why the world stopped building them. Somewhere between the erasures, the rewritten timelines, and the quiet disappearance of old-world technology, a thread was cut. Yet the stones still whisper, the patterns still repeat, and the buildings we were never meant to understand still respond to the planet as if waiting for someone, anyone, to recognize what they truly are. A message, a mechanism, a memory carved into matter itself. And if this is only the beginning of rediscovering those impossible materials, then perhaps the next discovery won't lie in the past at all, but in the moment we finally learn how to listen to what the walls have been saying for centuries.